Alright, so let's talk about the jump game forward. So jump, you are going to jump at most k step in an array, and yeah, you can reorder it. You want to return the maximum score you can get. So in this situation, don't think too much. You need to remember three rules. One is you want to keep in the k windows. So what does k windows mean? So if you're starting here, how many step you can go? You want to find out your value k, right? So if you are here, are you able to so if you are here, are you able to get this window? Definitely not, right? So you want to keep your windows in k size, right? In k size, and then this will be the first step. The second step is going to be get the update for the current score value. I mean the maximum score value, right? So you will just update your score value, update something like this. And third is you want to pull the last value. So you want to pull. So basically you are just add every single one value into the queue. Basically it's a queue, but you want to pull when your current score is greater than the next addition, right? So yeah, so I mean it would be easier for me to code. So let's look at it. So I'm going to create a DP and initialize to the num_length. And what you need to return is going to be return the last one, right? You want to return the last one for the maximum value, right? So return dp num_length -1. Alright, so what we need is we need an array deck, and then we need to store integer, right? Put the new array. So So in this library, we can pull first and pull last, offer first, offer last. So it will be super efficient. And then what I need is for my first value, dp0 is going to be equal to num_0 because this is the default case, right? And I'm going to make sure I have the 0 index ready since dp0 is assigned to num_0. So array deck is the index storage. So I'm going to start in from 1 and to the last one and plus. So the first situation is keep your windows in k size, right? So while the deck is not empty, and your I is the current position minus the value, the last value, or any value inside the deck. So it will be the pick first, because the first one in the deck is always the window, I mean inside the k window size. So if this is inside the window, it will be okay, but if this is greater than k, you want to pull first, right? Because this will not be inside the k window size, right? So what we need at the end, we definitely need to offer last. So we put every single index into the deck. This is how it's supposed to be. The algorithm is you keep your window size, you update your score for the maximum score, and you pull the value when you compare with your score. So second update score. So score AI, so which is going to be dp_ai equal to what? dpa, this guy, right? This is the value that we add because it's valid, plus the num_ai. So if we add the value add the current maximum value with the nums I. And if so, I added, right? But if so, I need to make sure it's not empty. If the dpi is greater than equal to dp.pick first, I'm going to pull because I no longer need this value. Sorry, pick last. So it has to be pick last because you add every single element into the last one in the deck, right? And then if this one, the current dp value is already greater than the value you add on the previous iteration, you don't need anymore because you know this. Sorry, it's a deck. Because you know, like, you have the current maximum. So imagine you add 4. Imagine you add 4 already. Do you need to add -7? No, you don't. So this will be it. So couple items. So pull last when you no longer need this value. Alright, so yeah, this is the algorithm for the jump question. So if you say jump k step, or you want to find out the maximum score between k windows, something like this is the algorithm. You just keep your pattern like this and you should be okay. So for the time and space, this is space, this is also space, all of n. And for the time, this is all of n, and this will be all of k, right? Depending on the size k. And this will be determined what is the last value you add, right? So this will be shorter than all of k. So personally, I feel it's going to be all of n times k for the worst situation. So this will be the solution, and you have to twist a little bit on this question. Like, you don't want to, add in and then find out the current maximum, max.max, and then, I mean, this is pointless. Basically, this is the optimal solution when you want to update the score without using the math.max, because we will pull the value when you no longer need it. Alright, this is a trick, and if you like it, leave a comment if you have a question. Then I'll see you later. Bye.